We saw two types of directives, structural and attribute directives. We also have custom directives. Before we move on to learning or understanding what custom directives are, let us start the session by understanding what dependency injection is and how DOM can be accessed or manipulated in Angular. Then we'll move on to custom directives. So to begin with, we'll see what dependency injection is. And before we move on to learn dependency injection, let us understand some concept like coupling. What do we mean by coupling? Coupling is the act of joining two things together. And in software development, coupling refers to the degree to which software components are dependent upon each other. So when a software is dependent on another software, like to install MS Office, we need operating system. So can I say like coupling refers to the degree to which software components like MS Office is dependent upon another software like OS. In object-oriented programming, to achieve a task, many objects need to communicate with each other. Like we have different objects that has to communicate with another object. These objects needs to be created before they communicate with each other. To perform some task, we need objects to do the communication, and before this communication happens, the first thing is we need the objects to be created. Who creates this object? A programmer can take all the responsibility of creating objects that are required to achieve the task. So as a programmer, we can create the objects that help us achieve some tasks. Like, let us see a class traveler. In traveler, we have an object creation, that is the car of type car equal to new car. So when we say this new car, we are creating an object of a class called as car. Once I have the object, I can say dot move. The traveler needs a car and is the same reason for creating a car object in traveler class. So if I am a traveler, I need a car to perform a task. So because I need a car, I am creating an object of that car. In this case, I say traveler is dependent on another object, that is car. I am dependent. I am, as a traveler, dependent on another object that is called as car, and so I create the car object. The programmer is manually creating the car object, that is, this is the car. I create, when I say new car, I get an object and I name it as the car. Technically, this case can be termed as tightly coupling. So coupling is the degree of dependency, and in this case my dependency is very tight, and so I term this as tightly coupling. Whenever the dependent class traveler creates an object on which the car is depending, then the procedure or pattern is called as tightly coupling. So in this case, you see, as I am a traveler and I need a car and I am very much dependent on this car, I am creating an object in my class. This is the case where we call as tightly coupling, tightly coupled scenario. The problem with tight coupling is whether the dependency class, that is car, is changed, the dependent class, that is traveler class, should also be changed. If I do some changes in here, I need to do the changes over here as well. So that is the reason why we call this as tightly coupled pattern. Cases like, what if car constructor takes an argument? If I take an argument over here, I need to pass an argument from here as well. So a change in here is causing a change over here. Then the creation of car object in traveler class should also be changed. Yes, we have to. What if car is tightly coupled with or dependent on a dependency class, say engine? What if this class, car class, is dependent on another class? Like we have an engine class, we write an engine constructor over here. Again, like a class dependent on other class, that class is dependent on another class, and the third class is dependent on fourth class. So this kind of dependency can go on. Tightly coupling leads to a lot of unnecessary code changes and makes unit testing difficult. A betterment to the above can be achieved through loosely coupled pattern. So the solution for tightly coupled pattern or approach can be resolved using loosely coupled approach. Let's see what is loosely coupled pattern is. In loosely coupled pattern, the dependent class, that is traveler, will not directly create the dependency car. So in loosely coupled pattern, we do not directly create an object the way we are doing in tight coupled pattern. Instead, we will have a different approach. Instead, the dependent class will be provided with the dependency objects. So what I'll try to do is, in loosely coupled pattern, I don't create this object directly. Instead, I'll be passing this required object over here. Now, how do I pass that? We'll see. So the change over here is traveler, and the constructor says will receive the car, and I assign it to the property of traveler. And I have function main in which I say new traveler, and now I am passing the new car object, and this receives over here, and I assign it to the property. Here we have avoided tightly coupled pattern by not creating the dependency object in the dependent class, instead passing it to the constructor from function. So the car object, I need the car object over here, and this dependency I am able to pass it from function main. I pass this required object, I receive it over here, and I assign it to the property of traveler class. So this is not tightly coupled. We have simply shifted the creation of dependency object from the dependent class to a different function. What is that we have done in this? We have simply created the object creation from this class to a function. Indirectly, the problem with tightly coupled is shifted to that function. Now, instead of creating an object in the class, what is that I have done? I have simply shifted to a function. It could be better if someone could take the responsibility of creating all the dependency objects. Again, this is also a change. Like if I need, or if there is a change in the car class, again I need to change my main function. So still the problem exists. Even if it is loosely coupled pattern, there is a problem, and that's the reason I am seeing for a better option. Like it could be better if someone could take the responsibility of creating all the dependency objects. Someone can take this responsibility of creating objects that I need, and this is where dependency injection comes in with frameworks. We need a framework which takes the responsibility of creating and passing the dependency objects to the dependent class. We need certain frameworks that take up all this responsibility and provide the object directly whenever I need it. So class traveler, and I say constructor private. This is just a reference to the object, from where will I receive the object? And that is where the dependency injection frameworks like Angular, Spring comes into picture. The framework provides the object runtime. All I need to do is use the object. Angular is a framework that supports dependency injection. It takes the responsibility of passing the dependencies at runtime, and all we need to do is to provide a reference. See, I am giving the reference, and this reference will be assigned with an object of car type, and this is done by Angular framework. This entire concept is called as dependency injection. Angular allows to inject the dependencies in multiple components across the application without needing to know how those dependencies are created and what dependencies they are dependent on. So this entire dependency of objects is taken care by Angular. So this is what dependency injection is.